Yeah, and I want to thank you. That was a wonderful and very in-depth presentation. A lot of the stuff, because I've worked in this area, a lot of the stuff that you said resonated with me. The pulsed current, I can't stress that enough. I saw exactly what you described. I've seen that in my own experiments. I think a lot of other people have as well. So let me do this. I'll set it up so that people can unmute themselves. Now I'll re-enable that.
Wow.
And who would like to ask questions?
Can I jump in?
Go for it, Mike. Welcome, sir.
No, it's a few hours from now. That's when you're supposed to. You're not allowed to.
Well, you guys are just discovering what we discovered a long time ago. When you get to AC, you'll get someplace. You're starting to get your pulse current. When you run the full sine wave, you get AC, and it works much better. We did a lot of this vortex work, laminar flow with about 35 kilovolts AC in my lab many years ago. The only problem is it's got an RF field so for super secret, it doesn't work very well because everybody sees you coming.
Yeah, so you can't use it in conjunction with the CMGs, the control moment gyros?
No, I don't think it would work on that, but we blew up a test fixture, supersonic test fixture in the lab with we were testing laminar flow at supersonic speeds. Wow. And the thing come unglued.
I see. So there's side effects from the high voltage. I see Hector Serrano's on the list of contributors here. Maybe he could tell us a couple words about the results of his patent.
Oh, yeah. Let me see here.
Yeah.
He's muted right now.
So. I'll ask Hector to unmute.
Yeah,
Hector,
what's up?
What's the update on your patent?
Oh, that thing's been abandoned. We don't do stuff like that anymore.
Disavowing knowledge. Same approach.
We don't. Yeah, that design. By the way, Jean-Louis Noudin tested that right after he saw it win the patent. You can go to his website and check it out. And you'll see that he did test it. He built like his, basically, literally took everything in the patent literal and kind of built it that way out of foam and aluminum and rigged it. Beautiful work. And we tested it. We worked and we just moved forward to another design to try to get a little bit better performance. And then later on, we are now in a third iteration of the whole concept that we've been testing.
And does it work?
Oh, the third iteration works a hell lot better than the last two.
Are you going to publish any results?
Probably not.
Oh, no.
I will. I'll put up videos, and I'm planning of actually allowing people to know like the moment of, the inertial moment of the device, so you guys can get your own, calculate your own performance based on what you observe from the videos and stuff. So you'll be able to have references and things like that, and we'll give you inputs and outputs. But what's inside the black box, nobody gets to see.
I was going to say, is it a black box we're dealing with?
Absolutely. Oh. It literally is a black box.
Well, now, if there's a way to ask Hector, I mean, Tom just made a really interesting case about patents being taken. So then are you going to do
We don't do patents.
Trade secret? Or?
Absolutely. That's the route we took. And a lot of the people that we're dealing with in tech right now and the ones we're forming joint ventures with are extremely happy that we're going the trade route direction and not the patent, because we simply, there's just too many, it's just too easy. Patents are just too easy to like rip off. So we're like, yeah, no, forget it, done. So, and that's also why our business model is, yeah, we'll provide services. So we're doing what we call vertical integration. We're going to be the operators of the CubeSat imaging system and things like that.
Wow. And you're producing a significant force from whatever voltage you're using?
Well, almost every single time we tested like the one you saw and in the patent and stuff like that, when we got it tweaked in just right, we would get between 24 and 31 millinewtons per watt.
Very good.
Yeah, so basically we, and what you would actually observe in a laboratory was in the range of like when we did the vacuum tests and things like that, if you guys saw, you can see those when we did those vacuum tests, those are still in our YouTube page. We were seeing about 4 millinewtons of force at around 16,000 volts and so. So, and like I said, that video is posted. You have to guess. I mean, we're doing that at what, 10 to the -6 torr. So yeah, visible thrust.
Wow.
You don't have to squint or guess. It's there. But you know, I've never. Look, I don't care if anybody believes or not. I just keep moving forward. so it's like I don't. You know, the market force is the only one I really care about. So, I have a different mentality, I guess, than most of my peers on this. And by the way, just so you know, Paletnikov actually was in contact. Well, Boeing was in contact with Paletnikov, and Paletnikov actually led them back to T.T. Brown.
Oh.
Yeah, I know that for a fact because I know the guy who actually told me that is from Phantom Works.
Mm-hmm. Interesting.
So.
You know, if I could jump in really quick, David just posted this in, just a reminder, he posted this into chat that Mark McCandlish passed away. I think this was probably about 2 weeks ago now.
Yeah.
Yeah, and that's there is a link to his obituary in there, and it appears to be confirmed. Now, I think we mentioned this at last week's conference as a possibility. Mark Sokol was, I think, one of the first people. He found this out while he was trying to do some conference lookups on Mark. He found the obituary, and so. But Tom, thank you for mentioning Mark's legacy. You know, in your presentation.
And we're happy to have his whole report. It was difficult to get Mark to agree to allow us to actually publish his entire report on the Norton Air Force Base craft. So I was pleased to get that involved into the book, and then he basically backed down and said it was okay. So I felt it was very important. But I have to give a lot of credit to Hector because he's basically told us and confirmed Townsend Brown's most controversial claim that this effect works in a vacuum.
Oh yeah, well we did it at the Leaf facility. First we did it with Purdue University in their own vacuum bell jar. Still got the video on that, but I can't show it because they own it. Then we did it at the Leaf facility, and then we did it again on our own. That was, and then Sonny White tested what we call second generation SFE as a confirmation effort for DARPA at the time, and they also saw force, very good force at that. So so yeah, we've never had a problem proving that there's a force present. In fact, that's the entire basis of our research. Is like throw away the ion wind, what's left? Why does that thing keep moving? Let's harness that because that's where the money's at. You know, literally that's the real deal. Everything else, yeah, it's okay. By the way, the modern term for the ion wind effect you guys are talking about is referred to as plasma actuators, and they're very popular now in the industry.
Oh, interesting. So you'll be able to go to Mars and maybe Alpha Centauri pretty soon.
That's what Boeing calculated. It's interesting. 12 years to Alpha Centauri.
You know, if I could jump in again real quick, Paul LaViolette is here. It looks like he has his mic hot. I'm not sure if he wanted to, if he had anything to say. Welcome, sir.
Yeah, whether he wants to go to Mars or Alpha Centauri, I'm not sure which one.
Yeah, I just want to comment about, you mentioned Jeffermenko. I just wanted to note in the equations, you don't see mass appearing, right? And whereas Townsend Brown was, his electrogravitic effect, he demonstrated depends on mass, that if you increase the mass between the electrodes, you get more force.
The dielectric, yeah.
Right. So, you know, there is probably a Jeffermenko effect, but there is also electrogravitic effect, similar to what Townsend Brown discovered.
And
also,
talking about, yeah.
Also about the use of he was emphasizing about charging and discharging the capacitors very quickly. He was interested in high frequency dielectrics, actually. And, the reason, and I gave an explanation in my book, in Secrets, that the reason his pendulum lost energy, it was just on the onset of the voltage, he would get thrust and then it would gradually subside, is because his dielectric was polarizing. And as the dielectric polarizes, it cancels out the field on the plates, in effect. So that's why.
That's true. Not in the two diagrams that we see in the how I control gravitation are not polarized. They're exactly symmetric, Paul. So,
well, in his capacitors, he was getting polarization. As any dielectric will polarize if you wait long enough. The dielectric polarizes, and it still works as a capacitor, but it loses its electrogravitic field, because when it's first applied, the field is first applied, that field is going all the way through the mass of the dielectric, whereas when the dielectric polarizing cancels out that, it's no longer going through.
The dielectric has what's called hysteresis. So
Yeah.
you can I used to do measurements at Hughes on infrared detectors, where they would make these capacitors, and you could they did what's called bias stressing, and by doing those tests, you could figure out the density of mobile charges in the depletion region of the diode. So it's a hysteresis. So you bias it one way, and then when you go and you switch to the opposite polarity, it takes some time to go back. So it makes kind of like a loop, like up and like an S with a space in between it.
So ideally, you'd want to put DC pulses on your capacitor, charge, discharge, but not reverse. And you can make use of that effect you just said about the polarization. If you pre-polarize a capacitor, then you can apply AC to it.
yeah.
And when the AC goes negative, actually the potential goes to zero instead of going negative, because you already have, it's bucking the polarization of the capacitor. So that's a nice effect that you can make use of with a tank circuit. You do AC with a tank circuit and pre-polarize a capacitor. You could use that for developing thrust by mass dielectric.
Well, thank you, Paul. And again, I think everything you guys are describing reinforces everything that we saw with the lifters when we were experimenting with those. The pulse DC, and Paul, what you were talking about was, biasing in AC. The best results that I saw were with a sharp sawtooth wave. We all started with those, computer monitor flybacks. I think that was the thing that everybody started with. And maybe by complete coincidence, that seemed like the best results that we saw came from that. But what you're describing with the biased AC would probably work just as well, So, and it definitely reinforces what Tom had said about Jeff Amenko's equation as well.
If I could just chime in on that, I actually tried that as well. Independent of all you guys, a couple of years ago, I had this theory that we should try sawtooth wave with a sharp rise time or fall time, basically slanted sawtooth. And I used triode vacuum tubes, I think actually 4 of them in series. They were all controlled via fiber optics. And it's one of the earliest videos on the Falcon Space YouTube channel. And I got like 70 kilovolts controlled in this sawtooth wave pattern. And the results were very interesting. Unfortunately, my scale went haywire and started showing like half a pound of weight loss. So I don't really trust that. I do want to try that experiment again, though.
Generate RF when you do that, by the way. That's
the scale went completely haywire. I couldn't.
Been there, done that. You got to Faraday cage it.
Yep.
Let me try and rope things back in. Who else has questions for
I did.
Tom?
I've been actually been waiting since we've got Paul and we've got Violette and we've got Valone in the same space, which is kind of awesome for electrogravitics, right? So I've played around with a lot of parallel plate capacitor configurations, asymmetric plate capacitor configurations, leaky dielectrics, not leaky dielectrics. I've tried a lot of things, and I can tell you for sure, just flat out, we'll close the case here. If there's no leakage and it's pure DC, if there's no current flow, there's no force. Just flat out. If there's no motion, there's no force. That we can say for sure. So this is, and you showed a picture earlier in the slideshow, this is one of those capacitors basically identical or almost identical to what was done in that test. It's a glass plate capacitor. Glass is slightly leaky, so it does allow us some small amount of current flow, which gives us a small amount of electron acceleration. But ultimately, the flow is in narrow regions. It's not evenly distributed. And so this system at 80 kV, I couldn't measure as much as 0.01 grams of force. So if it was producing a force, it was below 0.01 grams. And so even a symmetrical configuration with pure DC with a 10 kV pulse on top of it, we're still talking a measurement on my scale that's less than 0.1 grams. And so that could easily be within a noise floor still. So my issue is it doesn't seem to be that just a pulsed or a sawtooth waveform is enough. Even at 1,000 times faster rise time than the fall time, it still didn't give us hardly any force at incredibly high voltages. And so I guess my big question that's left me scratching my head for the last 21 years is, if it's simply pulse DC that doesn't work, if it needs to be incredibly fast, just how fast does it need to be in order to see these forces? Because I'm telling you, with slower speeds, we did not see them, and we've done a lot of tests.
Yeah, but also the shape of the positive electrode may be significant, as the Air Force Research Lab seemed to.
Did you guys ever see, well, this goes back to Campbell. Campbell and I go back away. Campbell's device, just so you guys know, let's put it on the record and you can double check with the FBI and the OIG about this. Because basically he learned that device was a replica of what we showed him over here in Florida. I won't go into the details of that. Like I said, we could spend quite a bit of time on that. Bottom line, after that, NASA paid I think it was the University of West Virginia to actually do some experiments for them to replicate kind of his device in vacuum. They didn't see much. It was really good experiment. I forget the exact group that did it. But what really astounded me was that when their system arced, it moved, and they couldn't explain it.
Yeah, the electron acceleration, right? Exactly, that acceleration moment.
They could not explain it. They calculated out down to the last atom, and it could not account anywhere near the observed force.
All right, the acceleration field isn't part of those equations now, is it?
Yeah, so it was very interesting. It was like it's probably the most the most valuable part of that whole set of experiments. They tried high voltage, they did it the normal way, and then when they raised the voltage a little bit above what the system can take, it snapped with an arc, and they saw it move, and they were like, well, we can't account for that. You know, they tried, they really did. And in their report, they say it's an unknown variable that happened there.
Paper is confirming that same thing, that you have to have a discharge or a current flow. There has to be, and not just a current flow either, not just a DC current flow. There has to be an acceleration. Without that, there's nothing.
I would say with lifters, and in fact, in many of the early videos now, we'd seen the same thing. Yeah, when there's an arc, right, like the corona wire, I mean, the earlier ones, you had lots of problems with that. And when there is an arc discharge, it jumps. So.
Well, as an example, Apoklanov's gravity impulse beam is basically a sawtooth wave. What it's doing is discharging suddenly through his anode to the cathode. And basically what he's doing is creating a gravity wave with the idea that electrons are antigravitic, and he gets a repulsive power from that. In my lecture a few weeks back, where I was talking about the Navy patents, analyzing them, that's essentially what they're doing. They're creating electrogravitic waves by, I believe, using sawtooth pulsations. They talk about using microwave sources there, but they don't say what the wave shape is, but I bet you it is sawtooth. And those waves are real waves that go out, and you can, in the case of the UFO, they're basically charging up the gravity potential outside the hull of the ship with these pulsations, these gravity waves. They're DC, they're Tesla waves, really. They're unidirectional, always in the same direction, pushing. Think of it as a pump.
Yeah.
And so I think some of these phenomena, that's what's happening with a sudden spark. You know, if you analyze it, figure where the electron's going, because electrons are the antigravitic part.
Oh, thank you, Paul. Yeah, and again, from my perspective, all of this stuff makes sense. Well, so let me go back. We're about 1:30. Does anybody else have questions for Tom? Because he covered a lot of area.
Oh, boy.
I do. So
Okay. Yeah, I was saying, go ahead. Go ahead, Michael. Sorry.
So I'm curious, Tom, if you've ever considered that, you know how electric field in the EM, the electric field and the magnetic field are 90 degrees out of phase from each other. So, so they have a phase difference of 90 degrees. So have you ever considered the possibility that the gravito-magnetic field would be at a different phase angle, say 45 degrees instead of 90?
Well, that's where Paul the Violet comes in. But theoretically, I haven't looked at very many theories that account for all the phenomena you guys have mentioned, and also all the phenomena that we've reported today. So
well, what I'm being more specific, I'm thinking if you think of a triangle wave, it's a, you know, a triangle wave.
I think
it's if you do a derivative of that with the 45 degrees, it's flat. It's like, so basically what I'm asking, so what the reason I raised this is because in my experiments, what I'm doing is I have to adjust the phase angle between the magnetic field and the electric field in order to get the readback signal from the MR resistor sensor. And it just turns out that that phase angle difference is at 45 degrees. And so that's why I'm curious if any of you have observed this effect of this phase angle difference between gravity and electromagnetism.
Well, like with Pakhnov's work, he doesn't use magnetism. They're pulses, so they're basically classify them as scalar waves, just pure electric pulse. But there is a patent by Wallace talking about varying, creating a gravito equivalent of a magnetic field, but with gravity. Where he uses AC somehow with certain types of conductors to transmit the wave. And so you get to the conclusion that there must be the gravity equivalent of the magnetic field also.
Yeah,
when you move an electric field, you create a magnetic field
just
and a motional gravity field.
It's at 45 degrees. And if you think of a sine wave, and how the signal scales, that would explain why gravity seems weak.
Because the phase isn't right, you mean?
Because the phase isn't right.
Mm-hmm. So what would you say is happening when you're changing to a 45-degree phase?
Well, I think what's going on is what's the most, this is just my, I'm just thought experiment. What's the most dense structure of matter, and the one that comes to mind is the diamond, and the diamond is called tetrahedral structure, and it has this 45-degree phase angle difference applies. That's what makes it tetrahedral, and so perhaps it has something to do with the stoichiometry of space-time. Maybe, so my thought is that space-time it's like even empty space has a stoichiometry.
So you're still working in Einstein's physics theory, are you?
Yeah, I think that would apply to his physics theory. I see how it would,
the ether has been validated with, there was a recent paper with the GPS satellites that shows that definitely it's.
When you say ether, do you mean the vacuum energy?
Yeah.
Well,
yes,
yeah, that there's
which Alputov says has no band gap, and all I'm saying is, yeah, it does, and that means it has a stoichiometry.
Well, look,
Okay, well-
from what I've heard, that's what the Black projects work with, is the ether concept. That I was told that by a fellow named Ray, who was the same guy that disclosed about the B2 charging swings, and that was published in
That was pretty cool.
Air and Space Technology. And they said it's based on Townsend Brown's work and Tesla's work, basically. And that's those two theories, put them together, explain the Navy patent. But Brown wasn't, he was looking into ether theories, and he was developing his own. And then there's Frank Ferguson's, whose father worked in the classified world in Washington. He was called in when there was the raid of the UFOs in '52 on Washington, and he was a radar expert, and they called him in. After that, he got involved in the Black projects, and Frank was a young fellow. Someday you might have him on the show to tell his story. And he was saying how they would get regular visits from a guy named Arnowitz, whose name appears, I think, in the Electrogravitic Systems document.
Oh.
And Arnowitz would have conversations with Einstein at Princeton, and he remembers Arnowitz telling his father that, well, you know, they don't go by Einstein's theory anymore. They're looking more like Heim and Burke, what's the other fellow's name? A German theorist. So they realized that Einstein's theory wasn't explaining what they're finding. But you should, I think, explore more of the ether approaches. And that's where the future is.
I would say Hal's hypothesis is in my mind it's using what the vacuum energy, and he's looking at it as essentially a bipolar, that there's still two types of this energy.
Yeah. That's one form of ether theory.
I'm not discounting the theory, just saying there could be alternatives that are just as valid. That's
okay. Well, guys, let me go to Will Riken real quick. And Will's had his hand up for a while. Will, did you have a question for Tom? We're getting off track a little bit, but I want to try and keep it focused on Tom's Q&A.
Okay. Yeah, Tom, I was wondering, you started out in college in homopolar generators. How did that translate into where you are now?
I don't understand the question. What was your question again? Could you repeat that?
You wrote the book Homopolar Generators.
Right.
And I was wondering, I believe that is the beginning where you began. So how did that get you to where you are today?
Oh, yeah. Well, that's a good point. Actually, I told my story at the citizens hearing back in, I think it was 2015, downtown National Press Club. And that's online. It's basically only a 10-minute YouTube video. We used to have it accessible from our website. And we may have it accessible again soon. But the important part is that I started with the homopolar because that was the information that I gathered from the Norman Paulson book, Sunburst, Return of the Ancients. And that was an intriguing book I read in 1980. I went out to the community, the Sunburst community, to basically just discern whether their invention was worth looking at. It was supposed to be a free energy device. And that's how I became friends with Bruce De Palma. And Bruce De Palma was a squirrely figure that basically kept getting investors to help them build another homopolar generator, which you would attach to a homopolar motor and claim that it would be over unity. Unfortunately, I was in between that and essentially a young grad student, so I ended up believing this stuff could be real, and I built my own homopolar generator. So magnetism became part of my thesis project for physics in sunny Buffalo. And I was fortunate enough to have a couple of professors who supported my investigation and the measurements I made, but I did measure back torque. So that was the kind of the deflating of the excitement that I felt for free energy. But then I was actually pursuing the Searle device, for example. Afterwards, I corresponded with John Searle. I actually met him in Germany when I was there to talk about the homopolar generator that De Palma was encouraging me to build. So John Searle's invention turns out has rotating homopolar generators around the outer edge. Those are the rotor magnets. So that became an interesting thing to help the Russians develop their patent and get funding for it. And basically I was helping investors get connected to inventors, and then they essentially go off into the sunset. And in that case, the Russian device never really worked. So unfortunately, Ivan Kruglock put a lot of money into it. And I believe, excuse me, Paul Murad perhaps has another continuing story on how that's developing, because there you have rotating magnets producing high voltage, and yet the homopolar generator normally doesn't produce high voltage. So if we have some type of capacitor effect that's continually adding small currents to get the high voltage phenomenon, that still is an anomaly right now. Searle effect is sort of out of reach for most people. But the interesting thing I found was here I started with a Sunburst book that dealt with a fellow, an earthling, having a UFO experience. And then I met John Searle, who had a UFO experience when he was young, started inventing afterwards. And then I met Roy Thornton, who developed this amazing inertial propulsion device. And he had the same thing, had missing time, apparently had a UFO experience, and then had lots of dreams on building devices. And in all three cases, the stuff that the Earthlings built, I wouldn't say even compares to what maybe the ETs have. Although we're trying our best to reproduce what we have, the limited downloads for our filtration system called the brain. So I became interested in UFOs as well, and that's what my citizens hearing testimony is all about. These trial and error sequences over decades of my life for the past 40 years, and essentially following up any trail that seemed to be viable enough to make sense. And of course, Townsend Brown sort of exists through all of that. I corresponded with Townsend Brown as well. Somewhere I've got a couple of letters from him when he became involved in the petrovoltaic effect after he gave up on electrogravitics. So, you know, all those guys are interesting, and I'm happy that I corresponded with one of the students from Jeff Menko's university, because he ended up following up with Jeff Menko's company in publishing his books. So the Jeff Menko causality book and electrostatic motors are still in print.
Tom?
Yes.
I was wondering, are you working with invisibility at all? Because we notice you sort of disappear when you leave your seat there.
I'm going back into the sunset.
When you got up, you actually disappeared at one point.
That's right.
Well, you know what? Actually, if I could jump in, I did notice Tom has a disappearing coffee cup as well.
Yeah,
I noticed that.
Yes.
Yeah. There it goes. Yeah.
Oh, it's beginning to look like Biden signing his presidential orders sometimes.
Yeah, invisibility, it's all, yeah, that's easy.
Well, Paul, did you have a question, or Will, did you have any additional questions?
I think Ben Development has a question.
Okay.
Yeah, one of the areas that we worked in is molecular accelerators. And it seems to me that some of the things that you guys are talking about fit within what we do. And we get up to 30 MeV from molecular accelerators. So these are, yeah. So I just threw that out that maybe that could be part of the effect. That's all.
Okay. You want to go into Ben? Ben's muted though.
Yeah. Let me see. Ben Solomon, right?
Mhm.
Okay, sir. Ben, are you?
He has to unmute.
Yeah. Okay.
My question is a little bit broader because I saw all your experiments and the research other people have done. So I was wondering, can I say, or is it 90% of the research into gravity modification is related to electrogravitics?
You could lump it into that title. I mean, it's sort of a catch-all for a lot of these experiments, but
Right.
It hasn't been defined as a real science yet. So there's lots of experiments that seem to contribute to that, and that's where Dr. Ning Lee likes the separation between magnetoelectric and magnetogravitic and electrogravitic. Gravitomagnetism, I believe she calls it, and gravitoelectric.
Why does she separate the two?
She's the only one that does, and you'd have to read her papers to fully grasp the experiments that she's done. Yeah.
People like to create their own terms to patent the word.
Yeah, it becomes patentable when you do that. That's the secret of getting a patent. Create a buzzword, and they can't search it. They never find it.
All right, thank you.
Sure. Here comes Paul. Now, Paul's getting all of these sterile devices from Ivan, the Russians had, millions of dollars worth of hardware, and he's going to be flying to Mars pretty soon, right, Paul?
Yeah. Actually, the one point I want to make is that Sheffimenko makes a gravitational law, and he not only attracts locations, but he also induces velocity. And what it says to me, that as you go faster than the speed of light, you lose gravity. And I'm saying to myself, I'd love to prove that.
Yeah.
I'd love to prove that. But, we're just not there. We're just not there.
No. Pretty soon.
Thank you, Paul. Does anyone else have questions for Tom? Who would like to go next? Let me see. I think I'm just reading through here. Lots and lots of quotes. Ed Becknell is wondering. Let me see about Faraday disks versus homopolar generators. Ed, could I get you to unmute, sir? There we go.
Yeah, let's see. I believe that question came from Jeremiah, was asking if I was familiar with a Faraday disk generator, and I was just curious, is that the same as a homopolar generator?
Yeah, is it?
Yeah, I can toss in. So there's this folklore that the disk in the center of the ARV somehow was a high voltage homopolar generator. And Mark McCandlish had mentioned that it could generate many thousands of volts, perhaps hundreds of thousands of volts. Now built four homopolar generators, the fastest of which was 32,000 RPMs, which is pretty fast for a homopolar generator. And I got an amazing 4.5 volts out of it, which for a homopolar generator is actually quite amazing. That's a lot of voltage out of one.
Yeah.
That's about the best I've ever seen. They generally generate voltages less than 10 volts at the very most. And so the idea of how it could generate anything above that, especially into like the ionizing potentials or what would be considered high voltage, even enough to feel, that's just something I've searched a lot for and couldn't find any references for. I even spent some time looking while Mark McCandlish was talking about it, hoping to get him to speak on some reference, but couldn't find anything. And I've spent many hours so far, no references at all. So if anybody at all here can show a homopolar generator producing high voltage, I'd be highly interested in seeing that phenomena.
Well, that's where the Searle device with a whole bunch of them around a roller magnet essentially becomes more an interesting geometry.
Well, the thing is, the Searle device, though, it's not homopolar, right? Because it's got dipoles that are rotating very, very fast. So it's a dipole generator with the generally homopolar construction in the center, but it's the dipole motion, the high volts or the high amps per meter, the rotating magnets around the outside that will produce that field, right?
No, but I don't have a diagram I can share real quickly, but essentially the roller magnets that go around the ring are individual homopolars, and they're polarized north and south, top and bottom. So, and they're rolling around the ring. That's the important part. They're not rotating independently, they're rolling around the ring. So you essentially do get a composite voltage that's, I would say, increasing with the rotational speed of the whole companion of that.
Can I point something out real quick, Tom? Because I've looked at the diagrams of the magnet configuration that he claims for the Searle effect generator, and they're basically split. If you were to take a cylinder and you were to split it down the side, and then you were to twist that split so it wasn't facing straight down, but so it sort of wrapped around, that would make not the top south and the bottom north or the other way around, but it would actually make one side generally south and one side generally north. So when it rotates, you would have a sinusoidal field that would be generated. And if you roll across a magnetic strip or you put it next to a coil and just simply rotated it, you would measure a sinusoid with the coil on the side. So that would be a dipole type generator. That's what I'm asking, is how is it homopolar?
Well, it's both. to be honest, you've got imprinted horizontal fields that essentially are well, what the Russians end up using, samarium cobalt, into a ferrite cylinder. And so you do have a sinusoidal imprint on the sides, but the top and bottom are north and south. So you've got both phenomena. But to be honest, the high voltage effect is still escapes most theorists and people analyzing that. So I sort of, just go back to the analytical or the anecdotal stories of various craft that seem to have high voltage effects.
And as a non-theorist, just an experimenter and engineer, I tend to go straight forward towards what can we actually do in our lab today. And when you come down to looking for that kind of information about high voltage and homopolar generators, there's, well, really everything lacking.
Well, Jeremiah, in terms of experiments, you've mentioned doing some work with Jeff Menko, right? Have you? Not
with Jeff Menko, no. I've never worked with him.
I mean, Tom, in your opinion, because I know Jeremiah and Mark are always looking for stuff to experiment with, do you think that might be an area where they might be able to do some interesting experiments?
Well, Jeff Menko's book on electrostatic motors is definitely a wealth of information on do-it-yourself things you can build, including we reprinted one article from Popular Science that tells you exactly how to build an acrylic electrostatic motor. So there are experiments that people can do at home to get high voltage from the atmosphere. And that's what Jeff Menko is also famous for.
Okay, it looks like, Tony, did you have a question, sir? Looks like you're unmuted.
Yeah, this is kind of directed towards Tom, but that guy Anderson who gave that presentation on his device at Coffee several years ago, I argued at that meeting that he was creating a homopolar generator that had dielectrics on the inside, such he was charging the inside electrode and then getting high voltage out on the inside electrode.
Anderson was the guy's name?
Yeah, he had that model that he always brung with him with the magnets rotating around. He had a company where they was claiming to get out, 100 and something volts out of it.
Right. Yeah, he's a great supporter of John Searle's device, and unfortunately, the model looks very nice when you push it, so that the roller magnets keep going around for a while and then slow down.
Well, that's kind of not the point. Just the fact that he was rotating them around, he's basically charging one capacitor of a dielectric with the charges from the homopolar generator, so that the inside one, which actually had a smaller area, so the voltage goes up on the inside dielectric. So you can end up, so there is a mechanism with that device for getting higher voltage out of a homopolar generator of that type.
Thank you. That's a very good point. I forgot the capacitive effects of the ring magnets, of the rings themselves.
And that would be a good experiment to try with these guys if they wanted to do something.
Well, Paul Murad should be doing that for us.
Well, I think Searle's device and Anderson's device is a little bit different. Yeah. Anderson was actually using electromagnets to cause the rotation around. So it wasn't, so he was putting energy into the system to get energy out, but the fact that it's a homopolar type generator getting high voltages is what I'm trying to point out.
Yeah, it's definitely still an experiment waiting to happen.
Yeah.
Hey, Tom, give me a break.
Well, yeah, actually, Paul,
You
since you
switch
jumped
it
in,
over.
HT Alvarez had asked if I could squeeze this in real quick. He'd asked about the amount of gravity in a warp bubble, and he said he had a related question similar to Paul Murad, in wondering if anybody was working on an answer for that.
Yeah.
Or
Paul Mira is working on it.
Yeah, I'm just kind of curious. I can't help but just look for the unknowns out there and see what's going on.
That's right.
I guess one of the viewpoints I used to have was that this stuff about these UFOs being in bubbles is ridiculous. Now I begin to believe that it's not the case. And the question here is, what do we have to do other than electromagnetics? The only thing we can say is maybe there's a torsion field, but what does that mean?
Yeah.
In other words, it's like looking at dark matter. What's a WIMP? It has no electricity, it has no charge. And then what is it? It's just black. Give me a break. So this bubble apparently can do something either in space or underwater. And I think the best way of looking at it is at this thing called Einstein rings. So all I'm suggesting is you might be interested in that.
okay, and thank you, Paul. Let me go to Gravity Alchemist. Sir, he's had his hand up for quite a while.
Hi. Hi. Hey.
Welcome
Can
back.
you hear me? Hey, great. Thanks. Can you hear me?
Yeah, you sound wonderful, sir. Go for it.
Okay. Hey, well, we were talking about homopolar motors, generating electricity, etc. I came across a YouTube channel, UFO Politics. I don't know if you've ever seen UFO Politics channel. And he follows this fella that's kind of on the edge with a lot of magnetism. His name's Ken Wheeler. And Ken Wheeler's, took some magnetic viewing film and puts it on a cylinder magnet. And you can see in the cylinder magnet, there's this, he calls it a line of inertia, or you can see it underneath the magnetism film, the viewing film. And it's what this guy does. He takes a cylinder magnet, puts a coil on it, and he has he has a bar of iron that's the same size as the magnet. So what he does is he puts the bar of iron and connects it to the magnet. When he does, that inertia plane moves up towards the bar of iron that he connects to the magnet. So you can see this inertia plane going up and down inside the magnet as the magnet doesn't move. He just puts a piece of iron on it. And then he has the coil of copper wires connected to an oscilloscope, so he can measure the voltage that he gets. So I was always thought you had to rotate the magnet to get an electric induction, but nothing moves except he just puts a piece of iron on it and gets a pulse. And then I guess if you put it on the other end, he gets a pulse, a negative pulse. If he puts it on the North Pole, he gets a positive, and on the South Pole, he gets a negative pulse. But I thought that it was like a little piston that goes up and down. And it's really interesting. So I don't know if anybody's ever done that or looked into that, but I just thought I'd throw it out there if anybody wanted to check that, or if you could explain to me what he's doing.
Could you, I missed I stepped out of the room for a second while you were talking about the name of the guy who you're referring to, and I caught everything else except for his name.
Oh,
this is a magnet, by the way, a neodymium magnet that's been stripped of its coating because, as you know, the plating that they have on these things is highly conductive and effectively shorts it out. What I found out is if you take a neomagnet like this and you wrap a coil around it, you've wasted your time because the physical material of the neodymium magnet is effectively a dead short as well. It's highly conductive. So for that, you need to use ceramic magnets or something else that's not conductive where you can actually get an impulse. Now, I tried that little thing with the coil. I tried the neomagnet with the coil, with the iron, and with another pulse magnetic field externally, and you can't get a pulse out of it for obvious reasons, eddy currents eat it. But I tried the same thing with a ceramic magnet, and you get a big old pulse. So the ceramic magnets do work because they don't short out the eddies that are externally imposed from the magnetic field, the shift of the poles that happens when you place the iron against
Well,
it.
I'm not sure if he used the neodymium or used some kind of different chemistry of magnet.
Well, let me jump back in here real quick because this is Tom's Q&A session. We're almost out of time. So yeah, we're right.
You answer my Okay, you guys are working on it. I can see that. I just thought I'd throw it out there because I thought it was really interesting. This piston of inertia plane and counter space.
Throw a link in the chat. I mean, that would be just really helpful, and then we can get right back to it.
Yeah. Well, and so yeah, we're almost. Let's do one more question for Tom, if that's okay. Or Tom, you were going to share. Yeah, go for it, sir.
Any gravity, folks? Any gravity, folks? With the serial device in the background.
That's so weird. All right. That's great. I wonder if there's a little bit of a wind attack over there.
Luckily, it's being pulled down and anchored, so it won't take off.
Maybe it might be a little wind. Look how beautiful that takes off.
Yeah, it's beautiful. Okay, there's my finale, the grand finale.
Oh, wonderful. Okay, well, let's do that then. Tom, I'm gonna put it back on gallery view, and everyone, please put your hands together and give Tom an enormous thank you for a wonderful presentation. That was tremendous, sir. Okay, so let me see.